is look at specific poker hands, how they're counted, and find out, for some of you know the game of poker, some of you do not. In the game of poker, some 5-card hands are better than other 5-card hands. For example, if you have all 5 different, that's not very good. If you have a single pair of cards, that's going to be better. Okay? At the beginning of this, we're going to write out a general rule that when we write it out the first time, it might not make sense. That's how trying to describe something in words in math sometimes is. Then we see a couple of examples, and then the rule might make more sense after. Okay? General rules. Okay? Choose we're going to choose the kind or type of card first, then the specific card. That's one of our general rules. Let's say if you have groups of types or kinds the same size, for example, 2 pairs or 3 single cards, you choose the types at the same time. These are our general rules, and right now, when you read those rules, you should feel a little bit like, I don't know what that means. When you see a couple of examples, we'll look back at the general rules, and hopefully they make a little bit more sense. So here's our first example. Example 1 is, in your 5 cards, you have a single pair. An example of that is, say you got 2 5s, and the other 3 cards are all different. An ace, an 8, and a king. That's an example of getting a single pair in the game of poker. So we need to know a few things about a deck of cards. Okay, some other things. Would you agree that you have 13 different kinds of cards, ace through king? And then you have 4 of each kind, because you have the ace of hearts, ace of spades, ace of clubs, ace of diamonds. That gives you 52 cards in total. That's how a deck of cards work. So if our general rules hold, and we want to find out how many poker hands have a single pair, okay? Well, we start by thinking about our pair. We could have a pair of 5s, pair of 6s, pair of 7s, pair of 8s. There would be 13 different kinds. We need to choose which one we're going to have a pair. After you choose one of those 13, in my example, I chose 5s. After choosing, first choose the kind. So now I've chosen the kind, 13, choose one. Then the specific card, or I guess I could write in bracket here, cards. For a pair, how many cards do we need? 2. How many 5s are there in the deck? 4. So when we choose the specific cards, we say, well, there's 4 5s. I need to choose which 2 I'm going to do. This together is a pair. And it counts all the pairs possible. And now to go with that pair, I need to choose 3 single cards. Since the 3 single cards are the same size, they're each single cards, when I go to choose which numbers I'm going to have or which kind I'm going to have, I need to choose that at the same time. Can you see that I can't pick a 5 now because 5s have been taken out? So for my 3 single cards, I now have 12 kinds left, and I'm going to choose 3 of them. In my example, I chose the ace, the 8, and the king. How many aces are there? There's 4 aces. I need to choose which one I'm going to have. There's 4 8s. I need to choose which one I'm going to have. And there's 4 kings. I need to choose which one I'm going to have. All of this together is 3 single cards. This was done together because they're all the same size, all single cards. Okay? So again, we'll revisit the general rules after we do 2 examples. Sometimes one example isn't quite enough to look at the general rule and feel like you understand it. So our second one. Oh, and by the way, if somebody could figure out the numbers here, multiply these all together, that would be great. The next one we're going to look at is 2 pairs. An example of that would be getting 2 8s, 2 queens, and 1 different number. That's an example of 2 pairs. What we do, we have to figure out our pairs. The pairs are the same size, so we have to choose them at the same time. So I have 13 different kinds. I need to choose which 2 numbers or which 2 kinds are going to be my pairs. I chose 8s and queens, but it could be kings and queens, aces and kings. You have to choose them at the same time because having 8s and queens is not different than having queens and 8s. Can you imagine? You play poker, someone says, oh, I have 2 8s, 2 queens, and a 7. The other person says, I win. I have 2 queens, 2 8s, and a 7. Like, that's the same hand. Just because you said your queens first doesn't mean you're better than mine. So we choose them at the same time. Then, well, if you chose 8s, there's 4 8s. We need to choose 2 of them. If you chose queens, there's 4 queens. We need to choose 2 of them. This together is 2 pairs. After getting our 2 pairs, we need to have 1 more card. How many kinds are left? Because we can't choose queens and 8s. Now there's only 11 kinds left. We have to choose 1 of them to go with our queens and 8s. We chose a 7. And then there's 4 7s. And I'm just going to put in brackets that if you took out all 4 queens and all 4 8s, there would be 44 cards left. And if you just chose 1 of those 44 cards left, it's the same thing as choosing the kind first and then the type after, or the specific card after. So now that we've done 2 examples, if we go back to the top and say, what are our general rules? We choose what kind of card we want first, and then what specific cards afterwards. That showed up in, for a pair, which number is going to be the pair, and then of those 4 cards, which specific 2 am I going to pick? And I like talking about it that way. Some people say pick the kind and then the suit. But it's a better visual of saying I've actually got those 4 cards in front of me. I'm picking 2 of them out to be my pair. Same thing here. Second rule, it says if you have groups of types of the same size. So in the first example, I had 3 single cards. In the second example, I had 2 pairs. The pairs are the same size because they both consist of 2 cards. The single cards are the same size because they're just 1 card each. So that's what I mean by if you have groups of the same size. You have to choose them at the same time. If you choose them differently, getting an ace and then an 8 is different than getting an 8 and then an ace. What we're trying to avoid is that overlap thing that we saw earlier with our question with the clubs. So here I chose 12, choose 3, and then did the specific card afterwards. Here I did 13, choose 2, and then did the specific cards afterwards. So this allows us to solve a number of questions with poker hands. It doesn't give us all the poker hands. Some of them will still involve some other strategies. But we're not going to do them all today, just these basic idea ones. First of all, has anyone figured out how many have a single pair out of the 2.6 million? No? Anybody figure out the second one? All right, we'll write down our numbers later. Three of a kind. That's when you get 3 of one kind and the other ones are different. Do you want to try this one on your own? See if you can use the strategy. I'll put it up in a second. All right, so there are the numbers from the first 2. There's over 1 million hands that have a single card. So out of the 2.6 million poker hands in total, 1 million of them have a pair. Okay, but only 123,000 that have 2 pair. When we get to 3 of a kind, okay, so we need to choose which card is going to be our 3 of a kind. And then if I chose the 2s, there's 4 2s, I choose 3 of them. And then of the 12 cards that are left, you need to choose 2. You need to choose those at the same time because they're single cards. And then 4 choose 1, 4 choose 1. And if we type this into our calculator, we get 54,912. So if you're wondering which is a better hand in poker, to get 2 pairs or to get 3 of a kind, it's less likely to get 3 of a kind. So that's why in poker, 3 of a kind beats 2 pairs. Okay, we'll do a couple more that aren't too hard to figure out. There's one that has a special name. It's called a full house. A full house in poker is 3 of one kind and 2 of another kind. So you could have 3 7s and 2 jacks. In this case, can you see that 3 jacks and 2 7s is different than 3 7s and 2 jacks? The sizes are different, so we count them separately. 13 choose 1, pick our 3 of a kind, 4 choose 3. And then there's 12 cards left. You choose one of them for your pair. And that would count how many full houses there are. The other thing these numbers off to the side tell us is how much better one hand is compared to another, right? If we look at from here to here, the first to the second one, you're basically from 1,000,000 to 123, just like 8 times, 7 times. This is 7 times better than that one. From here to here, it's just a little bit more than 2 times better. But then going from here to here, right, 4 times what is 54? It's like 14. It's 14 times better. So if you get that full house, it's significantly better than any other hand that you've had so far. And what happens if you were fortunate enough to get four of a kind? An example of that would be getting all 4 8s and then one other card to go with it. Well, you could have your 4 of a kind with any of the 13 cards, but then you have to choose all 4 cards. And then you have 12 kinds left to choose a single card. And whenever you're choosing just a single card, you might say, well, I could have also done that. That would have been fine. Because once you take your 4 8s out, there's 48 cards left. You just needed to choose one of them. And so if we figure this out on our calculator, we're only down to 624 poker hands. So getting 4 of a kind is really, really rare.